In the previous lesson, we discussed your options of imaging your membrane, whether it's wet or dry. A good measure for comparing these images is to calculate the signal-to-noise ratio. This is also known as the SNR. The signal-to-noise ratio is a measure of the signal for your target protein in respect to the background noise. When you analyze your target signal, you want to make sure that you have a high signal-to-noise ratio. You should choose the imaging method that yields this high value. For all subsequent blots, you want to make sure that all of your bands are above the signal-to-noise ratio, yet below the saturation limits, meaning that you don't want any bands that have saturated pixels because they cannot be accurately quantified. It's especially important to make sure that all of your bands are going to be within the dynamic range of your instrument. You should be able to see both your low and high abundant targets in one acquisition without any saturation. Also, you want to make sure that there's no visual artifacts, such as bubbles, present on your blot before you finalize your imaging session. It's important to remember that not all imagers will acquire the same image of your NIR Western blot. Western blot imagers have been developed with many different features and functions. You really want to make sure that your imager and software are not introducing any error or variability in your data acquisition. You want to watch out for software that can manipulate your data through binning or stacking. Binning is a form of image manipulation in which several pixels are combined to create one large, low-resolution pixel. Binning pixels will artificially increase your signal intensity, but it will also significantly decrease the resolution of your image. Stacking images combines several different acquisitions into one final artificial image. We will discuss binning and stacking in the image adjustment course in further detail. Both of these acquisition settings are forms of image manipulation. They are properly addressed in contemporary publication guidelines for Western blot data, and they should be avoided. When analyzing your blot, be mindful how the software handles these adjustments. Specifically, pay attention to the brightness and contrast and signal quantification. It's really easy to unintentionally introduce error during the image analysis. For more information on this, refer to the course on image adjustments. After acquiring your image, you can store your membrane for the short term in either PBS or TBS without detergent for up to 4 days at 4 degrees Celsius. You should not store your membranes any longer than 4 days, as you can see dissociation of the proteins from your membrane, and eventually you'll have fungal and bacterial growth. If you prefer long-term storage of the membrane, dry it completely and store it between 2 pieces of filter paper. Place the sandwich in a light, tight, and dust-free container, such as a Western blot storage bag. It could last in this condition for several years at room temperature. Store your membrane long-term in case in the future you have a new target and you'd like to reprobe your blot for it. Now, prior to drying and storing their membranes, some scientists do like to strip their blots. In the next lesson, we will discuss the best practices for stripping your blots.